Okay, so the last question of our panel today is, what's the biggest challenges of implementing RAG? And I'll go to Ofer first.
Yeah, so lots of challenges, but I'll mention 3 that are top of mind for me. One is trust and privacy, and I think most people I talk to in the community are talking about this. Like, how do I build a RAG system that does not, say, call some vendor outside and my data leaks and gets fine-tuned on or something like this. So I think security and privacy of data is one of the big concerns I hear a lot about. The second one is people talk about RAG and focus on the LLM. Are you using this LLM or this LLM? But the R in RAG is actually really important. It stands for retrieval. RAG essentially is a search-based system. You search your massive data of chunked data, however you do it, and you have to essentially be able to build a retrieval system that picks up the most relevant chunks of data to feed into the LLM. And again, we talked earlier about longer context. If the context is longer, you can do more, but you always have to pick some number of chunks that are relevant, and the retrieval becomes really important. So most people focus on, let's say, the vector search, the neural search part, but there's also hybrid search, which combines neural search and keyword search. There's things like re-rankers. There's a lot of different techniques that you can do to help make the retrieval part better. So I would encourage people to think about that, because when you scale, that becomes a much more difficult problem, is to get those right things. The third thing is, and it's something that we work closely with our customers. A lot of people are starting to think about this build versus buy, right? So I build a POC about RAG. I pick up the components. I do the 5 things I need to do on a small data set, and it seems to work great. And in 2023, it was like, oh, I'm a hero. One page of code, and I can build a RAG system. But when you scale this up in an enterprise context, it becomes much more difficult than you might imagine, and maybe you do imagine. It's difficult to maintain. It's difficult to update. When you scale, other systems come up, and this is not new. With enterprise deployments of other systems like databases and others, we've seen this before. So tech is just not easy that way. So a lot of people are starting to think about, okay, maybe we need to not build a stack, not become experts on sort of the stack of RAG, but rather on the app I want to build with RAG. So what's my data, and how do I build the application connected to this, and buying some solution that will help me run that process in parallel.
Marwan?
Yeah, I tend to agree that the main challenges go from going from POC to like production, and this happens on like different levels, from like preparing your data. So we've seen going from just text only to multimodal data, and the quality of the data and ensuring that the data doesn't have PII data means that even in your data preparation phase, you have to like combine model inference into your pipelines, and that means running on a heterogeneous cluster of compute and doing that in a very cost-efficient manner. So there's some benchmarks we've done by like indexing the entire Falcon data set that was used to train the Falcon LLMs. We did that with Pinecone, and we were able to achieve like 10 times cheaper costs on Ray. So you want like a system that like when you parallelize, you can sort of distribute the workload nicely. And then additionally, like on the performance side, like when you're deploying your LLMs, you also need to like have a good access to an inference engine that you can, very easily and quickly generate tokens.
Yeah, and you make a good point. The cost also is something that people don't think enough about. I think as you start like counting the tokens and how you pay all the vendors, it starts to add up pretty quickly.
Yeah, and at times, like at certain levels, like you might wonder if like maybe I'll do RAG sort of as batch inference on its own to generate, like certain things don't need to be like online running on like the most expensive GPUs. And so the more control you do have on your hardware, the more you can do of these trade-offs.
Yeah.
And I think this does also kind of tie in a little bit into fine-tuning, because we're talking about evaluations and agents, and each one of these is another LLM call with cost considerations and latency considerations. So this is kind of a use case, a strong use case for fine-tuned, local, quantized LLMs that you can run.